Okay, so today I'm also going to go over 6.1 area between curves. It's pretty straightforward section, and it kind of behaves like you think it would. At this point in your life, you guys should kind of understand the idea of how we're going to find this. When I talk about it, you guys will say, oh yeah, that makes a lot of sense. That's kind of what we're hoping for on this. So this is an application of what antiderivatives and not fundamental theorem calculus, what the definite integral can do for you. So remember, just the integral itself means basically find the antiderivative. However, the definite integral means find the area under the curve and between the curve and the x-axis, okay? So, but in those problems, if you're just talking about definite integrals can have negative area. So suppose you had a problem that was like this, and it was a curve down here. This area would be considered negative from A to B, because if you were doing the definite integral from A to B of f of x dx, you would get some negative area because it's below the x-axis. However, when you're talking about the area between two curves or the region between two curves, okay, you do not ever say the area is negative. The area is always positive. So what we're going to do is we're going to take and always calculate positive area in this sense, okay? So if you ever get a negative answer for these problems in 6.1, when you're drawing two curves and you're trying to find the area between it, you cannot have that. The areas can never be negative, okay? So that's one way you know you kind of messed up. So first thing I want you guys to do is, let's say that we had this. Well, this would be the integral from A to B if I wanted to find the area of this. And let's say that this is f of x, right, of f of x dx. That would be the area of that curve, okay? And then this area, this area would be the integral from A to B of, let's call this guy g of x, okay? And this would be of g of x dx, right? So that's how we represent that area. However, what if we stack these two curves on top of each other, and I had this area here, and then I drew this area here, and I wanted to find, you know what, that's actually, I shouldn't do it that way. Oh, I messed everything up. Hold on, guys, real quick. So this would be, so let's say we take those same two curves, but this time I want to know this area here. I want to know the area between the two of them. So what I would do is I would take the big area on top, the top curves area, and I would subtract off the little curves area, right? And what would be left behind would be this blue area right here in the middle. So that's the idea behind what I'm going to do here. So we would do top curve area minus bottom curve area, okay? But that in calculus terms means that we're going to do the integral from A to B of the bigger curve, which was f of x minus dx, minus the little curve A to B of f or g of x dx. And you could just go from there, but a lot of times we like to combine them and say f of x minus g of x into one integral dx from A to B, okay? So this is kind of the idea we're working with, all right? So the good news is in general, when you're working with these problems, a lot of the times in this section, and in the beginning, obviously things get much worse the higher you go in calculus or in math in general, but most of the integrals that we work with are going to be nicer than anything we ran into in the previous section in chapter 5. Everything we're going to be working with is normally a cleaner, easier integral because they figure, hey, you already got to do the setup. So I expect you guys to sketch every single one of these on your homework, or I should say on your exam when you do them. And this is something I really want you guys to practice doing. So you should get out your calculators and graph these and find all this information. So let's take a look at an actual problem. So let's say that we have find the area between the curves y equals x and y equals 6 minus x squared. Okay, so you guys should take out your calculator, or maybe you already know how to do this, which you should. This is actually the line y equals x, right? So I'm going to draw this guy in green. That's the line y equals x. So you guys get the idea. I kind of messed it up a little bit. And then the other one is a parabola that goes up 6, 1, 2, 3, 4, 5, 6, and comes downward. Oops. You get a general idea. I'm not an artist. You've all figured that out by now. Okay. And then we want to find this blue area in the middle. We want to find the shaded region. So the area between these two curves. Okay. So what we're going to do is we're going to do top curve minus bottom curve. So that means I'm going to integrate from somewhere to somewhere. We'll figure that out in a second. What's the top curve? 6 minus x squared minus the bottom curve, which is y equals x. I guess I don't need that. I guess I could write it like that. 6 minus x squared minus the bottom curve, which is x, and this is all dx. Okay. Now what we're missing is our limits of integration, and that we are going to find by finding the intersection points of this graph. So you could just set x equals 6 minus x squared. We could move everything to one side, equals 0, and then we solve x minus 2, or let's say x plus 3. X minus 2 equals 0, so x equals -3 and x equals 2. Those are my limits of integration, -3 and 2. Okay, that's how you find your limits of integration, is you find when the two graphs intersect, and that'll tell you when one is above the other. So now we can go through with the work. So we can now say that the integral of 6 is 6x minus x cubed over 3 minus x squared over 2 from -3 to 2. Okay, so now we just plug this stuff in, and we should get what? This would be 12 minus 8 over 3 minus 2, right? Because 4 over 2 is 2, minus, now this will be -18. This will be what? Plus 9. And this will be minus, oh, I don't know, 9/2. So let's see what this is on my calculator. Should end up being 125 over 6, but I'm just going to make sure I wrote everything right. 12 minus 8 divided by 3 minus 2 plus 18 minus 9 plus 9 divided by 2, math frac, and we get 125 over 6 like I thought. So this is correct. Okay. In general, fractions are better than decimals because normally the decimals are rounded and I want the fractional answer. So you get 125 over 6, and this would be the area of that shaded blue region. Okay, and that's all there is to it. And notice this was a nice integral, right? This was not hard to do. This was one of the nicer ones. You hope to get like these on the problems like this on the exam. But that's the whole point, is you're doing all this extra work with the shading and everything and the setup. So a lot of these problems are simplistic in terms of calculus, but in terms of concept and setup is a little more difficult, kind of like a word problem. And that's why it's called application of integration. So now we have one more. Find the area between y equals x cubed and y equals x for, and now they give me a value. They give me, I did it again, for 0 less than or equal to x less than or equal to 2. So they're telling me the interval they want me to check. Okay, so first thing you guys should be doing is sketching. Once again, draw your sketch. And when you do this on your calculator, you should get something like this. Oops, let me use a different color. So we should get something like that. And then you got y equals x. I guess I'll draw it in red. Y equals x should cut through it. Okay, and let's say that this is, oops, let's say that right here is about 2. And let's say about here is about 1. And let's say about here is -1. And again, that's not drawn to scale. I'm not perfect. So here's the thing. So we want the area between curves. So we say, oh, we got this area right here. That's good. And then we got this area here. That's good. And then so people would go and try to calculate this, and you'll get this problem wrong. Because first of all, they said that the area is between 0 and 2. So we actually do not care. So take a minute, pause the video, and try to see if you could set this integral up. The integral itself is easy, but see if you could set this integral up and find the correct area between the curves y equals x cubed and y equals x. Okay, so hopefully you guys unpause the video. Let's see what you got. So I know that what is the top curve? Well, the top curve is y equals x. So I'm going to say x minus x cubed dx, right? And then some people would write from 0 to 2 and they get marked wrong because y equals x is only the top curve right here. It's only the top curve right there. When you come to over here, it is no longer the top curve. So also, you got to understand that they said at x is less than or equal to 2. So they actually draw a line right here. There's an actual, the graph is cut off right here. So that means this is also blue because they didn't let it go to infinity, they cut it off. So I have to also shade the graph in here. So that means I have two different areas and this will not work. So what I need to do is I'm going to integrate from 0 to 1, and you could find this intersection point by inspection, or you could solve. You could do x cubed equals x, and then x cubed minus x equals 0, and then this becomes x times x squared minus 1 equals 0, so this becomes x plus 1, x minus 1 equals 0, so then x equals 1, -1, and 0. So you'd have your three intersection points. Here's the -1, here's the 0, here's the 1, right? Here's the 1 right there. So we're going to go from 0 to 1, and we know from 0 to 1, the x is on top and the cubic is on bottom. Okay, but then when we go from 1 to 2, the cubic is on top and the x is on bottom. Okay, and then these two areas we are going to add. We're finding two separate areas and we're going to add them. So this will end up becoming x squared over 2 minus x to the 4th over 4 from 0 to 1 plus x to the 4th over 4 minus x squared over 2 from 1 to 2. Okay, so let's plug this in. We get 1/2 minus 1/4 minus 0 plus that would be what? 16 over 4 would be 4 minus 2 minus 1/4, or I'm sorry, 1/4 minus 1/2. Okay. So let's evaluate this. I'm just going to use my calculator once again. 1 divided by 2 minus 1 divided by 4 plus 2 minus 1 divided by 4 plus 1 divided by 2. Math frac. I get 5/2, which is the correct answer. And we're good. So this is definitely a test question, one where you have to change your limits of integration to match the graph. This is something you should be ready to see on the exam. I put a few of these in the homework as well. All right. So now let's take a look at something a little bit different, and it's a little bit harder. Okay. So it says find the area of the region bounded by y equals e to the negative x, y equals x plus 1, and x equals 3. So let's take a graph of this. Okay. So let's see, y equals e to the negative x. So that's a flip of that. So I think when you graph this on your calculator, you should get, so let's say that that's 1 right there. You should get something that does this. Right, something along those lines, right? And then you got this other one that is y equals x plus 1. We know that that is a line that goes up 1. All right, so some kind of straight line like that, okay? And then we have this third graph that says x equals 3. So that's going to be like, I don't know, maybe over here somewhere. And that's this line. Okay, so we have these three graphs, and they want the area between all three of them. So that would be this section right here. Okay, so in this case, this would be the integral. So what's the top curve? Okay, well, so now they use three graphs, and it actually made it a nice problem because we know that we're going to start at 1. I'm sorry, we're going to start at 0 right here, right? That's where they intersect. And then we have the top curve would be x plus 1 minus the bottom curve, which is e to the negative x, right? And then we know that this is dx. And we know it's going to end at 3 because that's this guy right here. So now this just becomes the integral from 0 to 3 of x plus 1 minus e to the negative x dx. So I just rewrote it. And let's see, this would be x squared over 2 plus x. Now, if you want to integrate e to the negative x, well, we take the integral of e to the negative x dx. I'm going to take this and do a little side work. This is not the normal e to the x. This is e to the negative x. So somebody messed it up and made a composition of functions. So we say we're going to let u equal negative x, and then du is equal to negative dx. Divide both sides by negative 1. Oops. By negative 1. So now we have the integral of e to the u times negative du, right? Now I can just move the negative out front, and this becomes e to the u du, which is just negative e to the negative x plus c, but in this case we have definite integrals, right? So e to the negative x plus c, but and this is just like scratch work. So we're going to actually go that this is a negative e to the negative x, so we needed u substitution. So there's a negative in front, and then it's e to the negative x times negative 1. And then we're going from 0 to 3. So what I'm going to do is I'm going to clean this up. This is x squared over 2 plus x plus e to the negative x from 0 to 3. So hopefully you guys, that's just a little u sub. You have to do this whenever there's something inside the exponential, e to the 2x, e to the 3x, e to the 5x, you just let u be the power, okay? So we should end up with, let's see here. This would be 9 over 2 plus 3 plus 1 over e cubed, right? If I do it to the negative 3 power, okay? And then this will be minus 0 plus 0, but now this will become e to the 0, oops, plus e to the 0, which is actually 1, right? So let's see, we have 9 halves plus 3 plus 1 over e cubed minus 1. Okay, so let's do this on our calculator. We're going to have 9 divided by 2 plus 3 minus 1. So I get 13 halves plus 1 over e cubed. And that would be my area between these three curves, okay? So not so bad, but I just wanted to do one with a u sub on an e. I don't remember if I spent time on that in, I think I did a natural log. I may have skipped an e, but that's how the e's work, all right? So now let's look at a slightly different approach. So what if we have this graph? Find the area enclosed by the two curves y squared equals x plus 2 and y equals x minus 4. Okay, so this is, I think this will be one of the last ones we do. So now we're going to take a minute to graph this. So if you're not sure how to graph this guy here, you could think you're supposed to know that when you have the y squared, you have a horizontal parabola or a sideways facing parabola. When you have this situation, we could do it two ways. Okay, well, let's graph it. So if you need to, you could solve it on your calculator, and this would be the square root of x plus 2 and y equals negative square root x plus 2. That might help you draw it on your calculator, but in reality, it's a shift to the left of negative 2. So 1, negative 2. And let's see here. Here's negative 1, negative 2. Here's 1, here's 2. Let me do my best to try to draw this parabola. Okay, so we have something like that, okay? And then we have this line, y equals x minus 4. So minus 4 is down here somewhere, right? Sorry about that. And then this will be kind of, say it will cut right about there. And then it'll cut again right there. So let me see if I can get that to, oh, that's about as good as I'm ever gonna get. So let's go with that. So here's negative 4, okay? So we need to find this location here and this location here, okay? And you can do it by inspection or by solving or in your calculator. I think it can find your intersection on your calculator for you pretty accurately. Now, if it gives you decimal answers, that probably means you got to do it by hand because decimals will lead to incorrect final answers. We need exact values for these coordinates. I mean, if you were doing like in a computer class or something and they were asking you to approximate, then you could use decimals. But for us, we're going to need exact. So you could do this by inspection or whatever the case may be. But I have faith that you guys could find it. So we have it intersects at 7, 3 and 2, negative 2. Now the problem is, is we want this area, right? But if you notice, the parabola right here, the parabola is the top curve, but it's also the bottom curve right here, right? So you would have to do something that would go like this. The integral from negative 2 to right here to 2. So from negative 2 to 2. And the parabola, the top half of the parabola is square root of x plus 2 minus the bottom half of the parabola, which is negative square root of x plus 2 dx plus, now after we cut the graph right here, if we were to cut the graph right here, that means this part, you know, right here now has the parabola on top, the square root part on top, and now the line is on bottom. So then we would have to go the integral from, let's see here, from 2 to 7, where we have square root of x plus 2 minus, and then the line, which is what, x minus 4 dx. So that would be that parabola. And this is, you know, it's a little bit of a hassle. So there's a way we can do it where if we, instead of, it's almost like you turn it 90 degrees sideways, you change the way the graph looks. So if I were able to like turn this graph like that in a way, that would mean the parabola would become the top curve and the bottom curve would now be the line, but that would change the limits of integration to be working with the y's instead of the x's if we rotate it like that. So we could do it that way and it would work, but I want to show you guys how you can do parabolas or shapes where it's harder to discern what's the top curve and the bottom curve. So you can do right curve minus left curve instead. So we could use the integral of right curve minus left curve dy. So you can switch to dy if you want to do this. Okay, so this is a way you can do it. All right, and then that means you have to use different limits of integration that have to do with y coordinates because you're working with dy. So let's see how that would work. So what is the rightmost curve in this case? Well, you would have to solve for x. So that means that this would be y plus 4 equals x. And over here, this would become y squared minus 2 equals x. So we would have these two functions to now work with. So you know what, maybe I'll do this whole problem in blue because we're doing right curve minus left curve. So that means we're going to integrate from the y coordinates, which would be from -2 to 3. Right? So I'm using this coordinate and this coordinate. So I'm using y coordinates instead. And I don't have to split the integral now. It's just one big integral because it's much more obvious which is the right curve and which is the left curve. But I now have to write it in terms of y. So the rightmost curve would be y plus 4 minus the leftmost curve, which would be y squared minus 2 dy. You know what? I'll put brackets. Okay. Now we can clean this up. So now this will become the integral from -2 to 3 of y plus 4 minus y squared plus 2 dy. We can clean this up a little. This would be -y squared plus y plus 6, I believe. Let me see here. Did I do that correctly? Yeah. So it should be plus 6 dy. Now when I integrate, it's just -y cubed over 3 plus y squared over 2 plus 6y from -2 to 3. So you guys see that we did have to do a little bit of sneakiness. We had to switch the way we looked at the graph. It's almost like you turned it sideways. And then by doing right curve minus left curve, it made it an easier integral, but we had to account for that with different limits of integration. So now this is going to become, what, -9, because 27 over 3 is 9, plus 9 over 2 plus 18 minus f of b minus f of a. So this will become plus 8 over 3, right? Because it's a -y cubed. So that's a -8 times negative would be plus. This would become plus 2, and this would become minus 12. Now when we clean this up, we're going to end up with -9 plus 9 divided by 2 plus 18 minus 8 divided by 3 minus 2 plus 12. I just distributed the negative, and I get 125 over 6. Now if you look at this shape, you see this shape here? Let's go way back up here. Doesn't it kind of look like the same shape? And look at what we got, 125 over 6. So there's something you got to be careful of with that. But and remember, sideways area is the same as up and down area. It's still the same shape. It's just vertical versus horizontal. So that's pretty much that for 6.1. That was just one of those. There's a few of these in the homework I want you to practice of changing the limits of integration to match y and working with dy instead of dx. And it just makes the integral easier. But it would still have worked this way, but it would have just been a harder integral. Or sometimes it is, in this case, I think it's doable, but sometimes it's very difficult and you might have to do it the other way no matter what. All right, you guys, I'm going to go ahead and end the video on that note, but that will be your 6.1 video on area between two curves.